Hello and welcome. My name is John Hyatt and I am an automation solution specialist at Broadcom. Today, I'll be talking about the AutoSys workload automation JIL verification exit. Here's the agenda for today's presentation. I'll start by providing an overview of the JIL verification exit before advising of the usage requirements. I'll discuss implementation with an example of how to do so in a Linux-hosted environment. Finally, I'll illustrate 3 examples of how the JVE is being used by some of our customers today. The JIL verification exit is essentially an exit point written in C that is an extension of the AutoSys application server. The JVE provides a means of verifying or validating job definitions when adding, updating, or renaming a job. Among other things, Broadcom customers are using the JVE today to assist them to enforce site standards, maintain best practices, reduce the number of change rejections, and also streamline their alerting. The JVE can be used in a manner that allows job definition modifications to be made automatically, and as such, can help to reduce friction between the scheduling teams and those responsible for designing the AutoSys jobs. All of this is done before the job changes are committed to the database. Attributes can be removed and even modified, with messages transmitted to the user through the existing output channels. As the JVE is an extension of the application server, then it doesn't matter whether the change is made via the AutoSys CLI, the Web UI, IXP, or REST API. The verification will be executed. There are some requirements that must be met in order to use the JIL verification exit. Firstly, the code must be written in C and it must be compiled. The code must contain the AutoEXTVJ_ job entry point, and it must return one of either validated, modified, or denied. The shared library that is created must be named AutoEXTVJ and must be placed in the location specific to the platform on which the AutoSys instance is installed. Here is an example that illustrates how the JIL validation exit can be deployed on a Linux-based system. Once the code has been written, the GCC binary can be used to compile it. The first step in compilation creates an object file, shown in blue text here. The second step then creates the shared library, shown in green. The shared library must then be moved to the $AutoSys/lib directory, and the AutoSys application server, or servers in the event of the system hosting multiple instances, must be restarted. In this example on the Linux platform, the shared file extension is .so. This will vary depending upon your platform, but regardless of the extension, the shared library must be called libAutoEXTVJ. Let's look at some examples of how the JVE is being used by some of our customers. In this first example, the JVE is being utilized to remove native permissions from job definitions that are being loaded from the AutoSys CLI. This is an example of the code. I am using callbacks to retrieve the permission value from the JIL and, if found, the JVE will remove it. This code has been written such that a message will be provided back to the user to inform them that an amendment was automatically applied to the JIL that they submitted. Let's see this in action. Here is the JIL I'm preparing to load. As you can see, each job within the box has either group, user, or world execute and edit permissions. At the foot of the file, I am updating a box, adding permissions. Let's load the jobs into the system and take a look at what happens. The JIL verification exit has identified that each job has permissions, and it's removed them, writing a message in the output to inform me. The same has happened for the updated box, the last change that we made. When we review the job definitions that have been loaded to the AutoSys database, we can see that no permissions have been set. In the second example we'll look at, the JIL verification exit will be used to limit the number of retries that a job can attempt. In the code, We specify what the limit of the n retry value will be. For the purpose of this example, it's set to 2. The code will determine if the n retries value is contained within the job definition, and if so, compare it to the defined limit. If the specified n retry value matches or is below the limit, then the change will be applied. If, however, the specified value exceeds the limit, then the code will reduce the setting to the maximum permitted, which in this case is 2. Let's see this in action as we apply an update to an existing job from within the AutoSys web UI. In this demonstration, I'm already logged into the AutoSys web UI. I've navigated to the Quick Edit tab and I've applied a search in order to retrieve the job names and particularly the job that I'd like to edit. I'll open the job and move to the Schedule tab of the job properties. As we can see, right now, this job is not set with any retries. Let's set this value to a number that we know is within the threshold that the JIL Verification Exit will permit. If I save the job definition here, then the message is returned to the user to let them know that the job has been successfully modified. Let's try that again, but this time let's set the threshold or the number of n retries on this job definition to a value that exceeds the threshold that we've provided. Again, I'll save the job definition. And this time, the web UI is telling us that the job modification has been successfully made, but the custom job validation has modified the change and reduced the number of retries to the maximum permitted value, in this case, 2. And we can see that our job definition in the Quick Edit pane of the web UI is reflecting the n retries value that's been amended. We can verify that very quickly, and we'll move to the Quick View tab, and we'll run a refresh on the job definition here, and we'll see the n retries value has been reduced to 2. In the third and final example I will show, the JIL Verification Exit is being used to enforce a minimum gap between the execution of a job that is using the start_mins attribute. The code for this particular use case is a little more complex and difficult to display in a slide. So let's jump straight into seeing how this looks. This time, I'll attempt to add a job that starts at 1, 16, 31, 46, and 59 minutes past the hour. I'll do this via the AutoSys REST API. In this demonstration, I'm using Postman to connect to the AutoSys REST API and insert some jobs. As you can see, I'm inserting a box job and I'm inserting a job within the box. The box contains date conditions and will run every day of the week. It also contains the start_mins attribute. And as you can see, the box will run at 1, 16, 31, 46, and 59 minutes past the hour. These start_mins are 15 minutes apart, with the exception of 59 and 01, which are 2 minutes apart. The JIL Verification Exit code that we have created, compiled, and deployed will only allow jobs to run with 5-minute intervals at a minimum. Let's submit this change and see what happens. As you can see, the JIL Verification Exit has denied the change, and it's provided me with a message to let me know that the change has not been successful because the jobs are not permitted to run more frequently than once every 5 minutes. If you're interested in taking a look at the JIL Verification Exit, then check out the sample library. It can be located in the code directory on your AutoSys servers. The sample includes examples that cover a number of use cases. Please remember though, as with any changes, test in a lower environment before moving to production.